Hey everyone. In this video, we're going to talk about the Central Limit Theorem and sampling distributions. So if we have a population of mean mu and standard deviation sigma, we can take samples from that population of size n. And if we repeatedly do this, and we find, let's say we're looking for heights. We're looking for the height of the population. And so what we can do is we can take many samples of size n and from the population, measure everyone in that sample's heights, and then find the mean of that sample, the sample mean. Then I take another sample from the same population, random sample, same size n, measure all their heights, find the mean, and I keep repeating that process over and over again. The more I do that, I will start creating the data points that I'll start to have are the sample means that I've been collecting. And the more sample means I have, if I put them on a distribution, they will have certain characteristics. And by distribution, I mean if I made a histogram of all the sample means that I took. Now, if I take all of the possible samples from the population and I find the mean for each group, the mean of all of those means will be the same as the population mean. So the sampling distribution of sample means, so what that means is I'm taking all these samples and I'm finding the mean of each sample. And then I'm plotting, now I have a bunch of means as my data values. And if I use those means and I find the average of those means, the mean of means is going to be the same as the population mean. The standard error, which is the standard deviation of all of the sample means that I've gathered, is going to be equal to the population standard deviation divided by the square root of whatever size n samples I was taking out of the group. So as the number of samples gets larger, not the size of the samples, but the number of samples that I'm taking gets larger, the mean of my sample means will get closer and closer to the population mean. And that's what the central limit theorem is saying. The limit part is the more means I take, the more samples I take, and the more means I have to average together, the closer the average of all the means of each sample will get to the population mean. And the closer the standard error will get to the standard deviation of the population divided by the square root of the sample size. What's also true about taking all these random samples and finding the mean of them, the means will be normally distributed. They'll follow the normal curve if the sample size of each sample is greater than 30, or even if the sample size is less than 30, if the population was already normally distributed, then even if I take a sample size of 3 out of that population and I repeatedly do that, the mean of the means will also be normally distributed. But if n is less than or equal to 30 and the population is not normal, then we don't know what the shape of the sampling distribution will be. And that's important. If n is greater than 30, or if the original population was normally distributed, then we know that the sampling distribution of sample means, so this is a distribution made up of all these means that I took from all these samples, will be normally distributed.